This conference will now be recorded.
This is a software demonstration video to present introductory information about the Kendall-Theil Robust Line program, documented in U.S. Geological Survey Techniques and Methods Report 4A7. This program and the related documentation was prepared by the U.S. Geological Survey in cooperation with the Federal Highway Administration Office of Natural and Human Environment. This introductory software demo, which takes about 9 minutes, covers the theory and application of the Kendall-Theil Robust Line software, introduces the input file format, and shows the user how to launch the software. The learning objectives for this software demo are to become familiar with the KTRLine method, recognize the input file format, activate the program, select input and output files, generate the graph, manipulate the interpretive graphing and model specification form, transform the data, and specify and save a multi-segment model. The Kendall-Theil Robust Line is a linear regression model based on nonparametric statistics. The resultant equation of the line follows a standard format of the predicted variable, yi, being equal to the slope, denoted as m, times the predictor variable, xi, plus the intercept, denoted as b, plus the random error or residual term, denoted as ei. For the Kendall-Theil Robust Line, the slope is calculated as the median of all pairwise slopes among the data points. The intercept is calculated so that the line passes through the median of x and y data, and the random error component is the scatter of points above and below the line. This is an example of the derivation of a Kendall-Theil Robust Line. In graph A, with the predictor variable on the x-axis and the predicted variable on the y-axis, we see 6 data points and the 15 pairwise slope. Graph B is a schematic diagram showing how one would sort the slopes graphically to determine the median slope, designated as M. Graph C is a schematic diagram showing how one would take a line with the median slope and determine the intercept, designated as B, so that the line passes through a point defined as the median of x and y values. The Kendall-Theil Robust Line is considered robust because the median, slope, and intercept are not influenced by the values of a few outliers. Outliers are commonly found in many environmental datasets. Also, there is commonly substantial random variation in values above and below a regression line. The random error or residual EI for each data point can be calculated as the difference between the measured value yi and the value of the regression line at the corresponding predictor value xi. The population of these random errors above and below a well-specified regression model should, in theory, be a normal distribution with a mean and median of 0 and a variance, or standard deviation, that is not a function of the value of the predictor variable xi. In environmental datasets, these errors may be related to measurement errors or natural variability caused by processes not evaluated in the regression model. Although formulation of a Kendall-Theil Robust Line is not dependent on the distribution of these random errors, the statistics of the residuals do indicate the quality of the regression model. Finally, the statistics of the random errors can be used with the equation of the line for stochastic data generation. The Kendall-Theil Robust Line software is designed to facilitate development of multi-segment regression models. Multi-segment regression models are appropriate if different environmental processes are dominant over different ranges of the explanatory variable. For example, O'Connor 1976 demonstrates use of a theoretical two-line mixing model for river basins that have a relatively constant base flow concentration, Cg, below some threshold discharge, Qo, and either a positive or negative slope as rainfall runoff processes either contribute or dilute water quality constituents in the receiving water. Similarly, Glisson 1987 and Simon 1989 suggest use of 2 or 3 segment models to predict suspended sediment concentrations and loads to account for changing relations in the relative sediment availability and transport capacity with increasing stream discharge. This schematic diagram, modified from O'Connor, with discharge on the x-axis and concentration on the y-axis, shows the potential for increasing concentration or dilution from base flow concentrations as the base flow mixes with increasing volumes of runoff and the system transitions from being base flow dominated to runoff dominated. These asymptotic relations can be linearized by the Kendall-Theil Robust Line software provides statistics for the input data, the equation of the line, regression statistics, and the residual statistic. This information can be used to evaluate different data sets. These schematic diagrams show three possible scenarios to illustrate different regression lines and their error components. Graph A illustrates the scenario in which there is no relation between x and y. The slope is 0, the y-intercept is the median of the y population, and the median absolute deviation, or MAD, of residuals approximates the standard deviation of the whole random y population. Graph B illustrates the scenario in which there is a definite relation between the variables. The regression estimate y is the median of the y values for a given value of xi, and the median absolute deviation approximates the standard deviation of the local population of y values. Graph C illustrates the scenario described by O'Connor, with a zero slope in the lower range of x values and a non-zero slope in the upper range of x values. In this case, the population of residuals for each segment has a different median and median absolute deviation value. The Kendall-Theil Robust Line software requires a 2 or 3 column tab-delimited ASCII text file for the input file format. The user may create this file with a spreadsheet, text editor, database, or other software application. The first line in the file should be a tab-delimited text heading for each column that will be printed on the graphs and in the output file of the Kendall-Theil Robust Line software. Subsequent lines in the input file should have the XY data pairs to be analyzed. A third column, if provided, should include space-delimited metadata for each data pair. One may have a maximum of about 15,000 data pairs in the input file. This graphic is a screenshot of a Kendall-Theil Robust Line software input file in a text editor. The first line is the heading line. Because the file is tab delimited, with tabs denoted as greater than symbols in this view, the header text does not seem to line up with each column. This dataset includes 3 tab delimited columns that include water discharge, suspended sediment concentrations, and metadata. The metadata, which is space delimited within one tab delimited column, includes the data collection agency, the USGS, the 8-digit station number, and the date and time of sample collection. The metadata column is not required, but it may help identify outliers and potential effects of seasonality in the dataset. The Kendall-Theil Robust Line software has a data identification tool that will display both the data and metadata for points selected on the graphical interface. The user may choose to print this information to the output file. Now we will demonstrate use of the Kendall-Theil Robust Line software. To start the software, either click on a shortcut you have established on your desktop or navigate to the KTRLine directory installed under the program files and activate the executable program file. Use of the software is demonstrated in the next Captivate video. In summary, the Kendall-Theil Robust Line program is a robust method for estimating regression line coefficients and related statistics. It facilitates graphical model development by examination of data and residuals. It facilitates data transformation among the lateral powers, and it facilitates development of multi-segment models to characterize XY relations caused by 2 or more processes.